In this video, we are going to take all of the ideas that we've looked at before, shifting left and right, shifting up and down, reflecting, and doing stretches or shrinking. And so we're going to take those ideas and see if we can put them all together in one problem where we maybe don't have the picture. We're going to just think about what does that mean in terms of our function notation. So if we start with y equals x squared, and we want to shift that graph right 4 and down 7. So let's think about what that would look like. So let's ignore for a minute that it's y equals x squared. Let's say it's y equals f of x, where f of x happens to be x squared. So how do we shift that to the right 4? So if we want to shift that right 4, then we are going to have y equals f of x minus 4 on the inside of that function. If we want to shift that down 7, what do we need to do? Outside of the function, we need to just subtract 7. So if we want to write this function y equals x squared shifted right 4 and down 7, we're going to now have our function f of x is equal to x squared. So y, if it has this form, y is equal to our f is being evaluated at x minus 4. So we have x minus 4 squared minus 7. That shifts it, that takes an x squared graph, it shifts it right 4, and it shifts it down 7. Okay, so look at a second example. Here we have y equals the square root of x. So y equals square root of x. Let's instead think of that as y equals f of x. We want to stretch this vertically by a factor of 4. So how do we stretch vertically by a factor of 4? So for stretches, we're going to multiply the function by some value. So to stretch it vertically, we are going to have 4 times f of x. So that is a vertical stretch. What about our reflecting over the x-axis? So the x-axis, that's our horizontal axis. So to reflect over the x-axis, we need to take the negative of our stuff. So this is over reflecting over the x-axis. And then we want to shift it up 3. So to shift up 3, we just add 3 on the outside. So if we put all of that together, our graph, our equation is going to be y is equal to negative 4 times the square root of x plus 3. Oh, and that line up just above it, that should be an f of x right there. So if we think about what's happened with this graph, the 4 has taken a square root graph, the 4 has stretched it by a factor of 4, the negative there reflected it over the x-axis, and the plus 3 shifted it up 3. So we can build this function without actually having seen that function. Putting all those ideas together is important. So let's think about how that looks in terms of what order do we perform these actions in? Does it even matter? And the answer is yes, it actually does matter. And so the order of transformations, if we are graphing y equals a f of x minus h plus k, then this, we are first going to do a horizontal translation. You are translating negative h, like the opposite of the value of h itself. Next, you want to do any reflections any vertical stretching and vertical shrinking. So we want to do that prior to our vertical translations, because when we reflect that, we will reflect it and then go up 4 or down 4. If you go up 4 first and then reflect it, that's going to do not quite what you want. It's going to look way different. So you need to do that reflection, vertical stretching prior to translating it up or down. And then finally, we shift it up and down. So that's how we go through the process, putting all of those things together. Come back for one more video in this section where we are going to look at some special symmetries and we will look at some examples of those. We will see you there.